Hi friends, first of all let me introduce myself. I am D. Ganesh from TTWREIS Boys Kondapur. I am from 10th standard. Doctors suggest to eat one apple every day. Have you ever thought what is the nature of apple? It is acidic or basic? Right. Apple is acidic in nature. Apple contains malic acid. And regularly many people have the habit of drinking tea or coffee in the early morning. What is the nature of tea and coffee? They are acidic or basic? Right. Tea and coffee are acidic in nature. Tea contains tannic acid, coffee contains chlorogenic acid. And generally we use domestic cleaners like Lysol to clean our households. Have you ever thought what is the nature of Lysol? Means domestic cleaner? Yes, they are basic in nature. And soap which we use to take bath is also basic in nature. I think you guessed my topic. Right. Now I am here to talk to you about acids, bases and salts. In this class, you are going to learn about reactions of acids and bases, how acids neutralize bases and many more interesting activities that we use in our day-to-day life. Now first discuss about properties of acids and bases. Acids are sour to taste and acid turns from blue litmus to red. Means acids are sour to taste means, for example, if we take lemon is sour to taste, and if we taste it with the litmus paper, then it turns from blue to red. So it is an example for acids. And bases are soapy to touch and bases turns from red litmus to blue. For example, I said you that domestic cleaners are basic in nature. If we touch the domestic cleaners, we observe that they are soapy to touch, and if we test them with a litmus paper, then it turns from red litmus to blue. This is about acids and bases. And acids produces H plus ions in the aqueous solution. Aqueous solution means a solution in which water acts as a solvent. It is known as aqueous solution. Means when water is added to the acid, it undergoes dissociation and produces H plus ions. For example, if you take any two acids, for example, I will take hydrochloric acid and sulfuric acid. When I add hydrochloric acid to the water, it undergoes dissociation and produces two ions, H plus and Cl minus. Similarly, in the case of sulfuric acid, when I add sulfuric acid to the water, it undergoes dissociation and produces two ions. They are H plus and SO4 minus 2. The common thing is H plus ions are produced when acid is added to the water. So we can conclude acid produces H plus ions in the aqueous solution. And examples for the acids are hydrochloric acid, sulfuric acid, nitric acid, etc. And acids are two types, organic acid and mineral acids. Acids present in plants and animals are known as organic acid, and acids which are obtained from the minerals are known as mineral acids. For example, acetic acid, citric acid, formic acid are some of the examples of organic acid. Hydrochloric acid, sulfuric acid, nitric acid are some of the examples of mineral acids. This is about the properties of acids and bases. And bases produces OH minus ions in the aqueous solution. Means when base is added to the water, it undergoes dissociation and produces OH minus ion. For example, if we take sodium hydroxide and magnesium hydroxide, when we add sodium hydroxide to the water, it undergoes dissociation and produces two ions, Na plus and Cl minus, OH minus. And similarly, when we add magnesium hydroxide to the water, it undergoes dissociation and produces two ions, Mg plus 2 and OH minus. The common thing is when bases are added to the water, they undergoes dissociation and produces OH minus ions. So we can conclude that bases produces OH minus ions in the aqueous solution. Now let's discuss about indicators. Indicators are used to detect the nature of the solution to identify whether it is acid or base. In this class, you are going to learn about some synthetic indicators such as methyl orange and phenolphthalein. In the case of methyl orange solution, if we add acid to the methyl orange solution, then it turns into the red color. If we add base, then it turns into yellow. For example, if we add hydrochloric acid to the methyl orange solution, then it turns into which color? Right, it turns into the red color. If we add sodium hydroxide to the methyl orange solution, then it turns into which color? Right, it turns into the yellow color. In the case of phenolphthalein solution, if we add acid to the phenolphthalein solution, then it remains colorless, means it doesn't changes into any color. If we add base to the phenolphthalein solution, then it turns into the pink color. This is about the indicators. Now let's discuss about reactions of acids with metals. Before going to the topic, I will ask you one question. You have to answer this question after my first activity. Okay? The question is, why pickles and sour substances are not stored in the brass and copper vessels? You have to answer this question after my first activity. Okay, now let's discuss about reactions of acids with metals. Hydrochloric acid, sulfuric acid, nitric acid are some of the examples of acids. Iron, zinc, copper are some of the examples of metals. Now we are going to study the reactions of acids with metals. Aim of this activity is to observe the reaction of acids with metals. Materials required to conduct this activity are stand, test tube, delivery tube, rubber cork, vessel, soap water and matchbox. Chemicals required to conduct this activity are zinc granules and dilute hydrochloric acid. Remember that we must have to take dilute hydrochloric acid, and while diluting an acid we must add acid to the water, but not water to the acid, because dilution process is an exothermic reaction, means heat energy releases in the reaction. If we add water to the acid, then a lot of heat energy releases and test tube may breaks and it causes further severe burnings. So while diluting an acid we must add acid to the water. This is about the dilution process. We have to arrange all these materials as shown in this figure. First we have to take a stand, then we have to fix a test tube to it. Then take some zinc granules in the test tube and add 10 ml of dilute hydrochloric acid to the test tube and close the test tube with single hole rubber cork. Insert one end of the delivery tube in the test tube in the rubber cork, and other end of the delivery tube must be in the soap water. After arranging all these materials as shown in the figure, after some time we observe that some gas is evolved in the test tube. Gas evolved in the test tube passes through the delivery tube and forms bubbles in the soap water. If we bring a burning matchstick near to the bubbles, we observe that it burns by making the pop sound. Pop sound indicates hydrogen gas. We know that if we bring a burning matchstick near to the hydrogen gas, it burns by making the pop sound. So we can conclude that hydrogen gas is evolved in the test tube, means hydrochloric acid reacts with zinc, forms a zinc chloride salt and hydrogen gas. Here upward arrow mark indicates gas evolved in the reaction. When hydrochloric acid reacts with zinc, it forms zinc chloride and hydrogen. Here hydrochloric acid and zinc are the reactants, zinc chloride and hydrogen are products. If we generalize the reaction, we observe that acid reacts with metal, forms salt and water. So from this activity we can conclude generally hydrogen gas is evolved when acid reacts with metals. This is about the reactions of acids with metals. Now tell me why pickles and sour substances are not stored in the brass and copper vessels. Right. Pickles and sour substances are acidic in nature, means they contain acid. If they are stored in the brass and copper vessels, then they react with metal and spoilage of pickle will happen. So we won't store pickles and sour substances in the brass and copper vessels. Now let's discuss about reactions of acids with metal carbonates. We know the examples of acids. Hydrochloric acid, sulfuric acid, nitric acid are some of the examples of acids. Did you know which ion is known as carbonate ion? Yes, CO3- ion is known as carbonate ions. Metals with these carbonates are known as metal carbonates. For example, sodium carbonate, calcium carbonate, etc. Now we are going to study the reactions of acids with metal carbonates. Aim of this activity is to observe the reaction of acids with metal carbonates. Materials required to conduct this activity are stand, two test tubes, delivery tube, thistle funnel and double holed rubber cork. Chemicals required to conduct this activity are dilute hydrochloric acid, sodium carbonate and calcium hydroxide solution. Calcium hydroxide solution is also known as lime water. Formula for sodium carbonate is Na2CO3 and formula for calcium hydroxide is CaOH taken twice. We have to arrange all these materials as shown in the figure. First we have to take a stand, then we have to fix a test tube to it and add 0.5 grams of sodium carbonate in the test tube and add 2 ml of dilute hydrochloric acid. Then close the test tube with double holed rubber cork. Insert one end of the delivery tube in the rubber cork and other end of the delivery tube must be in the test tube which contains calcium hydroxide solution, means lime water. In the other hole insert the thistle funnel. Here the function of the thistle funnel is sometimes reactions won't take place properly due to the less acid present in the test tube. At this situation we have to add the acid to the test tube. If we remove the rubber cork to add the acid, then gas evolved in the test tube escapes into the atmosphere. To avoid this problem we use a thistle funnel. If we want to add the acid, means we will remove the cap of the thistle funnel and add as much as acid is required. Gas won't escapes from the thistle funnel because thistle funnel is dipped in the dilute hydrochloric acid, and this funnel is known as thistle funnel because it looks like as a thistle flower. On the screen you will able to see the thistle funnel and thistle flower. Both are similar, right? So this funnel is known as thistle funnel. We have to arrange all these materials as shown in the figure. After arranging all these materials as shown in the figure, after some time we observe that some gas is evolved in the test tube. Gas evolved in the test tube passes through the delivery tube, and when it passes through the calcium hydroxide solution, means when it passes through the lime water, it turns into milky white. It indicates carbon dioxide gas. We know that when carbon dioxide gas is passed through the lime water, it turns into the milky white. So we can conclude carbon dioxide gas is evolved in the test tube. Means sodium carbonate reacts with hydrochloric acid, forms sodium chloride salt, water and carbon dioxide gas. Here upward arrow mark indicates gas evolved in the reaction. Means sodium carbonate means metal carbonate reacts with acid, forms salt, water and carbon dioxide gas. Means if we generalize the reaction, we observe that metal reacts with acid, forms salt, water and carbon dioxide gas. We observed that carbon dioxide gas is passed through the lime water, means carbon dioxide gas is passed through calcium hydroxide solution. Then calcium hydroxide reacts with carbon dioxide, forms calcium carbonate precipitate and water. Here downward arrow mark indicates precipitate. The undissolved substance in the chemical reaction is known as precipitates. In this reaction, from this reaction, we observed that when the metal carbonate reacts with acid, forms salt, water and carbon dioxide gas. If we pass the excess carbon dioxide, means if we pass the required amount of carbon dioxide, then it forms calcium carbonate precipitate and water. If we pass the excess carbon dioxide, then calcium carbonate reacts with water and carbon dioxide, forms calcium hydrogen carbonate, which is soluble in the water. So from this activity we can conclude that the reaction of an acid with metal carbonates gives a corresponding salt, water and carbon dioxide gas. This is about the reactions of acids with metal carbonates. Now let's discuss about reactions of acids with metal hydrogen carbonates. We know the examples of acids, they are citric acid, acetic acid, etc. Now let's discuss about metal hydrogen carbonates. Generally HCO3 minus ions are known as hydrogen carbonates. Metals with these carbonates are known as metal hydrogen carbonates. For example, sodium hydrogen carbonate, calcium hydrogen carbonate, etc. Now we are going to study the reactions of acids with metal hydrogen carbonates. Aim of this activity is to observe the reaction of acid with metal hydrogen carbonates. Materials required to conduct this activity are stand to test tubes, thistle funnel, delivery tube and double holed rubber cork. Chemicals required to conduct this activity are dilute hydrochloric acid, sodium hydrogen carbonate and calcium hydroxide solution. Formula for sodium hydrogen carbonate is NaHCO3. Formula for calcium hydroxide is CaOH taken twice. Calcium hydroxide is also known as calcium hydroxide is also known as lime water. We have to arrange all these materials as shown in the figure. First we have to take a stand, then we have to fix a test tube, then take about 0.5 grams of sodium hydrogen carbonate in the test tube and add 2 ml of dilute hydrochloric acid in the test tube. Then close the test tube with double holed rubber cork. In one hole insert the thistle funnel. Thistle funnel must be dipped in the dilute hydrochloric acid. In another hole insert the delivery tube, and other end of the delivery tube must be in the test tube which contains calcium hydroxide solution, means which contains lime water. After arranging all these materials as shown in the figure, after some time we observe that some gas is evolved in the test tube. Gas evolved in the test tube passes through the delivery tube, and when it passes through the calcium hydroxide solution, means when it passes through the lime water, it turns into the milky white. It indicates carbon dioxide gas. We know that when carbon dioxide gas is passed through the lime water, it turns into the milky white. So we can conclude carbon dioxide gas is evolved in the test tube. Means sodium hydrogen carbonate reacts with hydrochloric acid, forms a sodium chloride salt, water and carbon dioxide gas. We know, can you tell me what is upward arrow mark indicates? Upward arrow mark indicates gas evolved in the test tube. If we generalize the reaction, we observe that metal hydrogen carbonate reacts with acid, forms salt, water and carbon dioxide gas. When carbon dioxide gas is passed through the lime water reacts with carbon dioxide, means calcium hydroxide solution reacts with carbon dioxide, forms calcium carbonate precipitate and water. If we pass the excess carbon dioxide, then carbon dioxide reacts with calcium carbonate and water, forms calcium hydrogen carbonate, which is soluble in the water. From this activity we can conclude that the reaction of an acid with metal hydrogen carbonate gives a corresponding salt, water and carbon dioxide gas. This is about the reactions of acids with metal carbonates and metal hydrogen carbonates. Now let's discuss about neutralization. The reaction of an acid with a base to give salt and water is known as neutralization. Simply, acid plus base gives rise to salt plus water. For example, if we take sodium hydroxide and hydrochloric acid. Hydrochloric acid is an acid reacting with sodium hydroxide. We know that sodium hydroxide is a base. Then it forms sodium chloride, salt and water. This is also an example for a neutralization reaction. Now let's discuss about reactions of metal oxides with acids. Reactions of metal oxides with acid is also an example for neutralization reaction, because All metal oxides are basic in nature. For example, if you take copper oxide, copper is a metal, copper oxide is a metal oxide. When it reacts with hydrochloric acid, it forms cupric chloride salt and water. On the screen you will observe the reaction. When copper oxide reacts with hydrochloric acid, it forms cupric chloride salt and water. So it is also an example for neutralization reaction. Now let's discuss about reactions of acids with non-metal oxides with bases. All non-metal oxides are acidic in nature. When they react with bases, they form salt and water. For example, carbon dioxide. Carbon dioxide is a non-metal oxide. When it reacts with calcium hydroxide, we know that calcium hydroxide is a base. When it reacts with calcium hydroxide, it forms calcium carbonate precipitate and water. This is about the neutralization reaction. And how many of you are suffering with acidity here? I think many of you, right? Acidity starts when pH in our mouth means in our digestive system, our stomach produces hydrochloric acid. It helps in the digestion without harming the stomach. During the indigestion, stomach produces too much acid. It causes for the pain and irritation. To get relief from this pain and irritation, people uses bases called antacids. For example, ENO. And these antacids are generally basic in nature and turns from then neutralizes the excess acid produced in our stomach. And these antacid tablets are prepared by the magnesium hydroxide, which is also known as milk of magnesia. And let's discuss about pH scale. Did you know who introduced pH scale? Right. pH scale was introduced by Sorensen. A scale used for measuring hydrogen ion concentration in a solution is called as pH scale. We know that acid produces H plus ions in the aqueous solution and bases produces OH minus ions in the aqueous solutions. This hydrogen ion concentration is measured by using this scale, and the P in pH stands for potence. P in pH stands for potence. Potence means power, and pH range of means the range of pH scale is 0 to 14, and pH of neutral solution is 7. Values less than 7 on the pH scale indicates acidic solutions. Values greater than 7 on the pH scale indicates basic solutions. Now tell me, what is the nature of a solution which pH value is 7? Right, it is neutral in solution. Means what is the nature of the acids are from 0 to 7. Means values less than 7 on the pH scale indicates acids. Values greater than 7 on the pH scale indicates bases. As pH value decreases from 7 to 0, it indicates an increase in H3O plus ions concentration. Don't get confused by H3O plus ion. I said you that acids produces H plus ions in the aqueous solution. These H plus ions can't exist as a bare ions, means they won't stay as a single ion, so they immediately react with water, forms H3O plus ion. This H3O plus ion is also known as hydronium. And values greater than 7 on the pH scale indicates bases, means values from 7 to 14 are known as bases. As pH value increases from 7 to 14, it indicates an increase in OH minus ions concentration. The strength of an acid or base depends upon the H plus or OH minus ions produced in the solution. For example, if we take hydrochloric acid and acetic acid of a same concentration, but they produce different concentration of hydrogen ions, the acid which produces more H3O plus ions is said to be a strong acid, and the acid which produces fewer H3O plus ions is said to be a weak acid. For example, in the case of hydrochloric acid and acetic acid, hydrochloric acid produces more H3O plus ions, so we can conclude it is a strong acid. Acetic acid produces fewer H3O plus ions, so it is a weak acid. Similarly, in the case of bases, bases which produces more OH minus ions are said to be a strong base, and bases which produces fewer OH minus ions is said to be a weak base. For example, if you take sodium hydroxide and magnesium hydroxide, both are bases, right? When sodium hydroxide produces more OH minus ions, so it is a strong base. Magnesium hydroxide produces fewer OH minus ions, so it is a weak base. Now let's discuss importance of pH in our day-to-day life. Did you know plants and animals also depend upon the pH change? Living organisms can survive only in a narrow range of pH change. For example, if pH of rainwater is less than 5.6, then it is called as acid rains. If acid rains flows into the rivers, it lowers the pH of river water, and survival of aquatic life in such rivers becomes difficult. How many of you are suffering with tooth decay here? I think many of you, right? Tooth decay starts when pH of our mouth is less than 5.5. Tooth enamel is made up of calcium phosphate, which is the hardest substance in our body. It doesn't dissolve in the water, but is coated when pH of our mouth is less than 5.5. Bacteria present in our mouth produces acids by the degradation of sugar and food particles remaining in our mouth. The best way to prevent tooth decay is to clean our mouth after eating food, and using the bases, using the toothpaste which are generally basic, and in this way we will prevent the tooth decay. Now let's discuss about salts. We know that salts are formed by the neutralization of an acid and base. Now coming to the families of salt, we know that the salts of salts having same positive ion or same negative ion have or belongs to a family. For example, if we take sodium chloride and sodium sulfate, sodium chloride and sodium sulfate have the same positive ion, so they belongs to the sodium family. Potassium chloride and sodium chloride, here these two salts have the same negative radical Cl minus, so they belongs to the chloride family. On the slide you will observe some salts. They are potassium sulfate, sodium sulfate, calcium sulfate, magnesium sulfate, copper sulfate, sodium chloride, sodium nitrate, sodium carbonate, ammonium chloride. Now tell me the formula of these salts. Yes, the formula for potassium sulfate is K2SO4, formula for sodium sulfate is Na2SO4, formula for calcium sulfate is CaSO4, formula for magnesium sulfate is MgSO4, formula for copper sulfate is CuSO4, formula for sodium chloride is NaCl, formula for sodium nitrate is NaNO3, formula for sodium carbonate is Na2SO3, and formula for ammonium chloride is NH4Cl. How many families can you identify in these salts? Yes, we identify 3 families. They are sodium family, chloride family, and sulfate family. Salts like sodium sulfate, sodium chloride, sodium nitrate, and sodium carbonate belongs to the sodium family because these all salts have same positive radical Na plus. And sodium chloride, ammonium chloride belongs to the chloride family because they have same negative radical Cl minus. Potassium sulfate, sodium sulfate, calcium sulfate, magnesium sulfate, and copper sulfate belongs to sulfate family because they have same negative ion SO4 minus 2. This is about families of salts. Now this brings me to the end of my presentation. Let's summarize what we have learnt. Acid produces H plus ions in the aqueous solution. Bases produces OH minus ions in the aqueous solution. Acids are sour to taste and turns from blue litmus to red. Bases are soapy to touch and turns from red litmus to blue. The pH value of neutral solution is 7. Values less than 7 on the pH scale indicates acids, and values greater than 7 on the pH scale indicates bases. Now I will ask you some questions. You have to answer this. If a solution have a pH value 7, then what is the nature of the solution? It is neutral or acidic or basic? Right, it is neutral in state. If a pH value of a solution is 7, then it is called as neutral, and if pH value of a solution is less than 7, for example, if a solution A have the pH value 6, then what is the nature of the solution? Yes, it is acidic in nature. If a pH value of a solution is 8, then what is the nature of a solution? Yes, it indicates base. This is about pH scale. And we learnt about the reactions of acids and bases. When acid reacts with metal, it forms salt and hydrogen gas, means hydrogen gas is evolved when acid reacts with metals. The reaction of an acid with metal carbonates gives a corresponding salt, water, and carbon dioxide gas, and the reactions of metal hydrogen carbonate with acid gives a corresponding salt, water, and carbon dioxide gas. The reaction of an acid with a base to give salt and water is known as neutralization reaction. This brings me to the end of my presentation. Now I am going to thank our beloved secretary sir, Ronald Rose sir, and my regional coordinator Nagarjuna sir, and especially our school principal Rajaram sir, and my mentor teacher Suresh Rao sir, and my housemaster Ram Gopal sir, and all our school staff who supported me, and my friends like my friend Jay Srikanth who helped me in presentation. I am thankful to all of them, and especially thank TSET channel for giving a golden opportunity. Thank you.